Hi everyone. So to extend what we did in class today, I'm going to be talking how we can solve for missing pieces in similar figures, knowing what we know about the definition of similar figures. So first, let me remind you, today in class we talked about that two figures are similar if their corresponding angles are congruent and their corresponding sides are in proportion, okay? All right, so let's look at these two quadrilaterals I gave you. It says quadrilateral ABCD is similar, it should have that similar symbol, to quadrilateral WXY and Z. It says find the measures of angle B, angle Y, angle D, and angle Z. So in class, we were writing correspondence statements. Since we're dealing with angle measures here, we know that corresponding angles would have to be congruent. That means equal. All right, so we see that. We can start, I'm going to start at C. I look at C. C corresponds to Y. C is 130 degrees, so that tells me that Y is 130 degrees. Okay, so I've got C taken care of. Then it says angle B. B corresponds to X. Okay, so X is 60 degrees, so then B is 60 degrees. All right, so we've got B and Y taken care of. Then we move over to D. D corresponds to Z. And what you might notice is that D and Z, both of them are missing an angle measure. So now this is where I have to use some things that we learned in the last chapter. I see these are quadrilaterals, so I know that the sum of the interior angles of a quadrilateral, is 360 degrees. So I have to find one of the missing angles. So we're going to start with Z. Okay, so we can do 90 plus 60 plus 130 plus Z equals 360 degrees. We add these together, so 90 and 60 is 150. 150 plus 130 is 280. So 280 plus Z equals 360. I'm going to subtract 280 from both sides. And so I get that Z is 80 degrees. All right, so if Z is 80 degrees, then angle D is 80 degrees. So that's one way we can use the definition of similar figures to help us find missing angles. But what about proportions? All right, so we're going to be talking about something called the scale factor between two similar figures. If PQRST is similar to ABCD, then we can say that their scale factor is, I look at the two sides that correspond, that I have a value for, and I looked and I saw ST and ED both had a value. So I can take those values and write a ratio, 20 over 32, and that we call the scale factor. That means that PQ, RST, and ABCD have a scale of 5 to 8. Why 5 to 8? Well, because 20 over 32, we're always going to want to reduce. So we would say our scale factor is 5 to 8. Now, the variable that I use for scale factor is K. So we're going to use that. So I would say that K is 5 over 8. All right, so let's talk about how we use that. Let's look at our first example. Two similar polygons are shown. It says find the scale factor of the polygons. All right, now you might notice that I used ABCD for the first one. And what I used on the second one was, I call this A prime, B prime, C prime, and D prime. When you do that, it means that A prime corresponds to A, B prime corresponds to B, C prime corresponds to C, and D prime corresponds to D. It just makes it a little bit easier. So sometimes you can see it like that. All right, so the first thing I do is I find a scale factor. I look for a corresponding side in both figures that I have a value for, and I see that DC and D prime C prime I have values. So I'm going to write a ratio with those sides. So K is 20 to 30. Now, you also could do 30 to 20. That doesn't matter, but you have to be consistent when you write your proportions. All right, I will simplify that. So my scale factor is 2/3. Okay, so I have my scale factor. Now I find the values of X and Y by writing in a proportion with my scale factor. All right, so I take the scale factor of 2/3, that's the ratio of the two figures, and we're going to solve for x. So I'm going to write a ratio, 2/3 or proportion equals x over 21. Now the x was from the smaller of the polygons, as was the 2, so that's why I wrote my ratio or my proportion that way. Now to solve the proportion, I cross multiply, and so I get 3x equals 42, and divide by 3, so x equals 21. All right, let's try another one. We take our scale factor of 2/3. We want to find y. So we've got, in our figures, we have 8 and y. So 2/3 equals 8 over y. We cross multiply and we get 2y equals 24. We divide by 2 and y equals 12. All right, one more. Last example. We take our scale factor of 2/3. We're trying to find z. Okay, now z is in the larger of the two. So I'm going to do 10 over z. I cross multiply and I get 2z equals 30. I divide both sides by 2, so z equals 15. So that helped me, that the scale factor helped me find missing sides because I know that they are in that ratio. All right, so let's plug in our values here. We've got x was 21, our y was 12, and our z was 15. Okay, so now let's find, it asks us to find the perimeters. All right, so let's do the perimeter of the small one. So perimeter of A, B, C, D. You add up the sides. So you do 21 plus 10, 21 plus 10 plus 8 plus 20. Add up all the sides to get the perimeter, and that gives me a perimeter of 52. Then we're going to do the perimeter of A prime, B prime, C prime, D prime. So we would do 15 plus 30 plus 12 plus 21. And if I add those up, it looks like I'm going to get 78. All right, so we have our two perimeters. Now it says find the ratio of the perimeters. All right, so to find the ratio, remember we compare them. So we would do 52 over 78, and then we would simplify. Okay, well, I see that 2 goes into them, and I actually also see that, does 4 go into? 4 goes into, 4 does not go into them. So if I divide by 2, I'm going to get, let's see, 2 goes into 52 26 times. 2 goes into 78 3 and 18, so 39 times. And hopefully you're seeing now that 2 was not the largest common factor. It actually was 26. But now it's 13. So if I divide both of them by 13, I'm going to get 2/3. So I'm going to ask you to think for a second. Your scale factor was 2/3, and the ratio of the perimeters that you got simplified to 2/3. So what did you notice about the scale factor and the ratio of the perimeters? Well, hopefully you're saying to yourself that they are the same. They are the same because if every side is in the same ratio, when you add all the sides together, they will be in the same ratio. All right, and that brings us to our next little theorem. The theorem's called the ratio of the perimeter theorem, and it says if 2 triangles are similar, then the ratio of their side lengths so their scale factor is equal to the ratio of the perimeters. All right. So let's try it again. What I'm going to ask you to do is I want you to try it now. I want you to find the scale factor on the next page of A, B, C, D, and A prime, B prime, C prime, D prime. Find the values of X and Y and find the ratio of the perimeters. So I want you to press pause, try it and come back and I will put the answers up for you, okay? All right, you pressed pause. You tried these, A, B, and C. You're back. You should have gotten a scale factor of 50/30 and simplified it to 5/3. And I did from A, B, C, D to A prime, B prime. Then you find the values of x, and I got x equals 18. I got y to be 20, and I got z to be, I think, 13.2. It also asked to find the ratio of the perimeters. No work was actually necessary. You did not have to calculate the ratio of the perimeters because if two similar figures have a ratio of side lengths of a scale factor, the scale factor and the ratio of the perimeters are equal. So K would be 5/3. All right, let's try a harder problem. Okay, so we're looking at the example. ABC, triangle ABC is similar to A prime, triangle A prime, B prime, C prime. The scale factor is 7 to 9. So I know that K is 7 to 9. If the perimeter of ABC, of triangle ABC, is 42, find the perimeter of triangle A prime, B prime, C prime. Well, if I know the scale factor, I can actually use ratios and proportions. The first thing I'm going to do is I'm going to let x equal the perimeter, which is what I'm trying to find, the perimeter of A prime, B prime, C prime. And then I'm going to write a proportion. So I know my scale factor is 7/9. All right, so 7/9 equals 42/x. All right, now yes, I could cross multiply, but I want us to try that technique we talked about in class. I'm going to use the properties of proportions because I see the 7 and 42 and I know that they are factors of each other. So one of the properties of proportions allows me to write this slightly different. So I'm going to do 7/42 equals 9/x. I'm going to use the properties of proportions to change the proportion. I'm going to simplify 7 into 42 to 1/6. And now you might be seeing why I did that, because it made an easier problem that I could do without a calculator. So I cross multiply and I'm going to get x equals 6 times 9, which is 54. So the perimeter of ABC is 42 and the perimeter of A prime, B prime, C prime is 54. Okay, what I want you to do is I want you to try the next example and bring it to class tomorrow, and we are going to be practicing this as we move into more on ratios of figures and ratios of perimeters. All right, guys, have a great night.